Hello everyone, this is Dan and welcome back. We are continuing our inverse function series, and this time we're looking at exponential functions. So exponential functions are normally in the form of y equals ab to the x plus p plus q. But for this, we'll use the simpler version of just f of x equals b to the x. To get the inverse, you do the same thing we did for our linear functions and our quadratic functions by just switching the x and the y and then solving for y. So let's do an example together. We want to find the inverse of the function f of x equals 2 to the x. So we first write it as y equals 2 to the x. Then we swap our x's and our y's. So you get x equals 2 to the y. Now we want to solve for y. So we take the log of x equals the log of 2 to the y. But if you remember your log properties, when you take log of a base to a power, you can bring that power all the way to the front. So this becomes log x equals y log 2. And now we can treat log 2 as a coefficient and divide both sides by log of 2. So then we get y equals log of x over log of 2. And if you remember one more of your logarithmic properties, we can say y equals log base 2 of x. And so in order to put this in function notation, we say the inverse of f of x equals log base 2 of x. And that would be your answer. Now, there's some properties that we need to go over. First of all, b has to be greater than 0. And this is true because if b was less than 0, when you take b to the y, it'll oscillate between positive and negative values. b also cannot be equal to 1 because 1 to any power is just 1. And x has to be greater than 0 because any positive number to any value is greater than 0. Now, there's also some log properties that we'll need to go over. You guys have gone over this in detail before, so we're just going to do a quick overview. So if you have, this is one of the properties that we just used, when you have log base b of a to the x, you can take the x and bring it all the way to the front. So it's x log base b of a. If you have log base a of a, that's just equal to 1. And this one we also just used. If you have log base b of x, it's the same thing as saying log base a of x divided by log base a of b. In ours, what happened was we were using a base of 10 for both, so we are already on this right-hand side of the equation. So we had log base 10 of x divided by log base 10 of 2. So that's how we got to log base 2 of x. Some more properties is that if you have log base 2 of x times y, you can just add the individual ones. And if you have log base b of x divided by y, you can subtract them. And then if you have log and there's no base put there like we were doing before, it's assumed to be base 10. And lastly, if you have log base b of 1 equals 0, this just states that the log of 1 with any positive base is equal to 0. Okay, so let's try another example together. So we want to find the inverse function of f of x equals 8 to the x. So we're going to say y equals 8 to the x. And now we're going to swap them. X equals 8 to the y. So we're going to take the log of both sides. And we know that we can bring this y to the front. And now we know that we can divide by this log of 8 on both sides. And we get y equals log 8 over, or log x, over log 8, which is the same thing as saying that it's equal to log base 8 of x. So to put our function notation, we'd say the inverse of f of x is equal to log base 8 of x. And that would be our answer. Now, if we take this and we put it into a graph, we can see what our functions look like. Now for this, our f of x, we want to know what does this equal to. So if we look at the red line, we can see that the domain is all real numbers. And if you remember what we were doing before in terms of domain and range with our inverses, you know that this domain becomes this range. So the range is then going to be all real numbers. And if you look at the blue line, you can see that that's true. But now let's look at the range for our f of x. Here we have y is greater than 0. And that's going to be true for the domain of our inverse. We're going to have x is greater than 0. And now we want to know what are our intercepts. So the intercept for our original function is 0, 1. As you can see, it intercepts right over there. But for our inverse function, it is now 1, 0. And it intercepts right over there. So again, you can see all they did was they swapped their x's and their y's. And so the asymptote for our original function is the x-axis. But for our blue function over here, which is our inverse, it's going to be the y-axis. So those are examples for the exponential functions. If you guys have any questions, don't hesitate to ask us in the Ask a Tutor function or during our live lessons. I hope to see you guys soon, and I hope you had fun. Bye.